Hello everyone. In our previous lecture, we had covered the topic of thermodynamics. In this chapter, we are going to have a discussion over electromagnetism. Okay, so let's start. So basically, the first question is, what do you mean by electromagnetism? Basically, this word is comprised of two words. Electro stands for electricity and magnetism stands for magnetic effects. Okay, so basically we are going to discuss about the electricity and its magnetic impacts. Got it? So let's start. Basically, here are two particles. One is charged and one is negative, about which we have to discuss in this chapter. Okay, there are two particles, positively charged and negatively charged. Got it? So we have to discuss about these particles in this chapter. Got it? And these particles have a relation between them. Which relation is stated by the electromagnetism. Got it? Okay. So basically, here we have a first law. Which is a Coulomb's law, because it was given by Coulomb. It was given by Coulomb. Okay, so that's why it is called as the Coulomb's law. Got it? And basically remember two things. First is electric charge. Second is electric current. Electric charge is a static form. Electric current is in the motion form. Okay. So when there is only a particles, then it is a electric charge. And when there is a motion, then it is a electric current. Electric charge to electric current. Got it? The difference between the electric charge and the electric current. And the another thing is the electric charge has unit Coulomb, where the electricity having unit, the electric current having unit ampere. Okay, so the electric charge having a unit Coulomb and the electric current having a unit of ampere. Got it? So basically, come to the Coulomb's law. Okay. So the Coulomb's law states that the force between two charged objects is directly proportional to the product of their charges and inversely proportional to the square distance between them. Okay. Basically, if there are two particles or two charged objects, it is A, it is B. Got it? So force of attraction between them simply means that two charged particles will attract each other. Two charged particles will attract each other. Okay, so we have to discuss about this property. Okay, so if there is a one charge particle, particle A, and another charge particle, particle B. Okay, so they both will be attracted to each other, but the force between two charged particles, the force of attraction between those two charged particles will be directly proportional to the product of their charges. The more charge they carry, higher the force of attraction. Got it? The less charge they carry, lower the force of attraction. Got it? So simply means if they having a higher charge, then their force of attraction will be more and they could attract each other with more intensity. But if their charge is low, then the force of attraction between them will be low and they cannot attract each other with great intensity. Got it? So it was the first statement, or you can say first interpretation of this law. The second interpretation is related with the distance. Suppose it is A, it is B. At first, they are placed at a distance of 10 meter. In second case, it is A and it is B. In this case, it is B. In this case, they are placed at 40 meter distance. 40 meter distance, here they are at 10 meter distance. Got it? So in that case, first case and second case, during the first case, the force of attraction between them will be more. And the second case, the force of attraction between them will be low. Okay? Because force of attraction between these particles is inversely proportional. Okay? So basically, if here I am presenting the force of attraction by F and distance by D. Okay? So basically you can say if D is higher, force of attraction will be lower. Or if D is lower, the force of attraction will be higher. Got it? But in case of our first scenario, where I am presenting charge product of the charge by P and force of attraction by F. If the P is higher, F will be higher. If the P is lower, F will be lower. So in this case, there is a direct relation between the product of the charges and the force of attraction. And in this case, there is a negative relation between the distance between the objects and the force of attraction between the objects. Got it? So it was the first Coulomb's law or first law of electromagnetism, you can say. Okay? So now let's come to the example. Imagine you have two balloons, one with a positive charge and the other with a negative charge. When you bring them close together, they either stick together or push each other. Coulomb's law helps us understand why this happens. Okay? So basically, in our examples, we didn't mention the positive and negative charges. We just only come to know about this. But in this example, we have to start with the positive and negative relation, about which I have just mentioned. Okay, so remember the force of attraction and force of repulsion. Got it? So they are two terms. First is force of attraction and another is force of repulsion. The force of attraction is when A and B will attract each other. Okay? And the force of repulsion is when both A and B repel each other. Got it? So basically, when it happens, remember, statement 1, statement 2. Positive and negative charges always attract each other. Got it? Whereas same charges, whether positive or negative, will repel each other. Okay, so whenever they are the opposite charges, there will be a force of attraction between them. But whenever there are the same charges, there will be a force of repulsion between them. Okay, or you can say the positive and the negative charges, whenever they come together, they will attract each other. But when the same charges, whether they are the positive and whether they are the negative, come together, they will always repel each other. Got it? So now let's understand it by the example, or we can say change this example into the action. Got it? So suppose if there is one balloon A, and another balloon B. Got it? Balloon A is positive, balloon B is negative. It was the first case. In the second case, balloon A is negative, balloon B is negative, or we can say balloon A is positive or balloon B is positive. So in this case, balloon A and balloon B will attract each other. Whereas in this case, both A and B will repel each other. Similar in this case, they will repel each other. Okay, understood? And this is happening because of the Coulomb's law. Because Coulomb's law stated as the force of attraction between the two particles is directly proportional to the product of their masses, of their charges, and inversely proportional to the distance between them. Got it? Now come to the point that it says that opposite charges attract each other, as I have told you. Like the positive balloon and the negative balloon get stick together, while similar charges repel each other, like two positive balloons pushing each other away. Or you can say two negative balloons pushing each other away. Got it? Now come to the next point. It is the electric circuit. So what do you mean by electric circuit? Basically, point A, point B, point C, and point B. The electric circuit is basically a closed part through which electric current can flow, typically comprising components like wires, resistors, capacitor, and power sources. Basically, you can say if this is an electric wire, then there is an electric charge. This is an electric charge. Electric charge. Okay. point A, point B, point C, and point D. And this is a electric charge between this. Okay. So when this system is closed, as you can see, this system is closed by four sides: side A, side B, side C, and side D. So there is a flow of current. There is a flow of current, or you can say there is a flow of electric charges. Electric charges, and as I have told you, when the electric charges are in the motion, they known as the electric current. Got it? So the closed path through which the electric current can flow, it's known as the electric circuit. Remember, always remember, electric circuit should be closed. Okay, let's take an example of this photo. If you can see in this photo, the system is not enclosed. The system is not closed because the current will flow from this, comes to this, and here there is no path to reach this point. Okay, so in this scenario, when you will touch this pin, which is made up of steel or iron, okay, so when you will touch down this pin to this, then there will be a bridge. So the current which will start moving from this side will continue its journey to moving to the entire path in a circular motion, and that's how the electric current will be set up in the electric circuit. Got it? Now in this example, think of a toy car has a little battery inside that gives it power. When you switch on the car, the battery sends electricity through the wires just like magic paths to the motor of the car. This makes the car move. The wires, battery and motor together make an electric circuit that allows the electricity to flow and power the toy. So let's convert this example into action. Okay, so this is our toy car. This is powered by the battery. Okay, and in this battery there is a system like this. Okay, positive system, negative system. Okay, so the current will start moving from this area to this area. Okay, but in between there is a gap, and this gap is because of the switch of the car. When the switch is off, circuit is not closed. As you can see, when the switch is off, circuit is not closed. But when you on the switch, then the circuit is closed. Circuit is closed and there is a complete flow of current. Okay, so here we have finished this concept. Now come to the next concept, which stands for the magnetic field. Okay, so magnetic field is a region in space where a magnetic force can be experienced. Okay, so in your childhood you must have come to these two magical things, like A, like B. Okay, so you all know these two magical things, which whenever put together they always attract each other. Okay, and always attract towards iron, nickel, and other iron containing objects. Okay, and these two particles we used to call, or you can say we call them even today as magnets. Got it? So magnets are basically the objects which attract each other or attract towards another magnet whenever they keep together. And second thing, magnet is an object which always get attracted towards iron, nickel, and other items which containing the iron parts. Got it? So basically the area where the magnet gets placed, like this is a magnet, so there is a area where it has its magnetic impact. Where it has its magnetic impact. And this magnetic impact is known as magnetic field. Suppose you have some iron nail. You have this iron nail. If you put this iron nail here, then it will not attract it towards this magnetic field. But in another case, if this is the magnet and this is the magnetic field, you put this iron nail inside this magnetic field, then it will be attracted towards the magnet. Okay, so that is the example of the magnetic fields. Got it? Now come to the another example. Imagine you have two magnets. When you bring them close together, they either stick together or push each other away. That's because magnets have invisible hooks called magnetic fields. These magnetic fields make the magnets act like magic. They can either pull things together or push them apart. Okay, so to understand this example basically, or to change it into the action, let's understand one fact, that magnets have poles. Magnets have poles, and these poles are basically terminal of magnets. Terminal of magnets, like in this case, these are the poles represented by N, the north pole, and the S, the south pole. Okay, and the magnetic field lines originating from the north and converging at the south. Got it? Outside the magnet, you can say outside the magnet, magnetic field lines originating from north to south pole. From north to south pole. It's basically the case of outside magnet. Okay. While in the inside magnet, the magnetic field is originated from the south and converging at north. Inside magnet, it's originating from the south and converging at north. Got it? So here we have come to know about the magnetic field lines and their origin also. Got it? So basically the magnets has their poles. Okay, and these poles also contain the opposite. Okay, like south pole is opposite to the north pole, and similar the example of electricity, or you can say the electric charge, as the positive and negative attract to each other, or you can say the positive will repel each other, or the negative will repel each other, similar as an electric charge. Magnet also does the same thing. Okay, so here north will attract to the south because they are the opposite one, while the north or the south will repel each other. Got it? And this is because of the north and south terminals, which is called the invisible hooks called the magnetic fields. Got it? Because of this, they attract things, and because of this, they repel things. Got it? And also the two magnets may be attracted to each other, or maybe repelled to each other. Got it? Because of north and south pole or because of the terminals of the magnet. Got it? Now come to the magnetic induction. Okay. Basically, it is a magnetic induction refers to the process by which a magnetic field is created and material when it is exposed to an external magnetic field, leading to the alignment of its atomic and molecular magnetic moments. Okay, so basically it says that whenever there is a magnetic field, there will be always a electric field, or you can say whenever there is an electric field, there will always be a magnetic field. All right. All right. So remember these 2 points. Whenever there is an electric field, there will be a magnetic field, and whenever there is a magnetic field, there must be a electric field. Got it? And this concept was given by Faraday. So that's why there is also known as Faraday's laws. Got it? So in this chapter, basically we had covered the electromagnetism. Got it? In our next lecture, we will start with the optics. Till then, thank you.